Today's notes over conic sections involve converting from general form to standard form so that you can graph the conic section. A lot of times you might see this as converting from general form to graphing form, but the method that we're going to use is completing the square. Now, if you've watched this unit or you've been with this unit from the very beginning, the very first lesson in this unit, we reviewed completing the square, and we're going to be putting that into play in today's lesson. So the general form of a conic section is written ax squared plus by squared. So I have my squared terms first, x being the first squared term, then plus by squared plus cx plus dy plus e equals 0. The steps that we're going to take, we're going to group our x terms and y terms on one side of the equal sign, and we're going to move the constant to the other side. The next thing we're going to do is we're going to factor out any GCFs in our x terms and y terms if necessary. We're going to complete the square for x terms and for y terms. So it's like we're completing the square twice. And when we do that, we're adding b over 2 squared. That's that number that everybody forgets. We're adding b over 2 squared to both sides. And then we're going to factor and write in graphing form. So when we look at a circle, here's a circle that's written in general form, and you can identify that this is a circle because my x squared and my y squared terms are on the same side of the equal sign and they have the same coefficients. So just looking at this equation, I can identify this as a circle. So what we're going to do is in step 1, it says we're going to group the x terms and y terms on one side and we're going to move the constant to the other side. So what I'm going to do is rewrite this as x squared minus 4x plus y squared minus 10y, and I'm going to move that negative 7 over to the other side. I've grouped my x's and my y's together. I've moved the constant to the right. Now what I'm going to do is I'm going to complete the square for this term, these terms, and this term. So what I'm going to do is x squared minus 4x, I'm going to add something to here, plus y squared minus 10y, I'm going to add something to here, which I wrote a plus sign there, equals 7. So now what do I add? I add b over 2 squared. Now I'm going through this fairly quickly because we did review completing the square a little bit at the beginning of this unit, and you hopefully have seen completing the square when you have solved quadratics, things like that. So x squared minus 4x, when I add b over 2 squared to that, I get negative 4. That's the b over 2 squared, which is negative 2 squared, which is positive 4. So I'm going to add positive 4 right here. What I do to one side, I have to do to the other. Now we're going to look at the y terms. Negative 10, this is the value of b. So b over 2 squared is negative 10 over 2 squared. Negative 10 is negative 5. Negative 5 squared is 25. So I'm going to add 25 to both sides. Now what I have done here is I've created this perfect squared trinomial here and this perfect squared trinomial here, and I can factor that in a binomial squared. So the binomial squared, this x trinomial factors into x minus 2 squared, right? So negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. That's how that factors. Plus, this perfect square trinomial factors into y minus 5 squared. You take half of that b term. That's all you do. Equals 7 plus 4 is 11. 11 plus 25 is 36. And now I have a circle. Let's graph it. The center is going to be at 2, 5. 1, 2, 1, 2, 3, 4, 5. We can graph that center point. And the radius is going to be, remember, the equation for your circle is x minus h squared plus y minus k squared equals your radius squared. So your radius is going to be the square root of 36, which is 6. So I can go out 1, 2, 3, 4, 5, 6 units in every direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It goes one more up off our coordinate plane to graph points on this circle. And that's how you do that when you have a circle. Okay, and these won't be labeled on your assignment, but you can identify them because we've already done a lesson over identifying conic sections. So let's move on to an ellipse. How do we convert this from general form to standard form or graphing form? Well, the first thing I'm going to do is group my x's and y's, move the constant to one side. So I'm going to rewrite this as x squared plus 8x plus 4y squared minus 48y equals negative 144. And then I am going to, because right here I have a coefficient in front of this y squared. Remember, you need to have a coefficient of 1. A needs to be 1 whenever you're completing the square. I need to factor out a 4. So I'm going to rewrite this as x squared plus 8x, and I'm going to factor out a 4. So plus 4, and I'm left with y squared minus, when I factor out a 4 there, I get 12y equals negative 144. What I'm going to do now is I'm going to rewrite this x squared plus 8x. I'm going to add something here, plus 4 times y squared minus 12y. I'm going to add something here, equals negative 144. What do we add to both sides? I'm going to add b over 2 squared, remember? So right here, what do I add there? I'm going to add 8 over 2 squared. That's 4 squared, which is 16. I'm going to add 16 here, and I'm going to add 16 here because I do it to both sides. What I do to one side, I have to do to the other. Now, right here, what do I add? b over 2 is negative 12 over 2 squared. That's negative 6 squared, which is 36. I'm going to add 36 here, but we factored out a GCF of 4. I cannot just add 36 to this side and it be the same amount. I have to add 36 times 4, which 36 times 4 is 144, and that's what I have to add to this side, and that's what you have to remember. A lot of students forget that. If you factor out a GCF, remember, this C term that you're adding to both sides, you need to multiply that by that GCF and add that number to both sides. So now this is going to factor, okay? Here's my perfect square trinomial. That factors into a binomial squared of x plus 4 squared. This right here is 4 times, that's a perfect square trinomial. It factors into a binomial squared of y minus 6 squared equals, when I add all of my numbers up on the right, those cancel out and I'm left with just 16. So now what I need to do is, I can tell that this is not a circle, and so this is not going to be a radius over here on the right, which I'm not able to change. Oh, I can change colors now, which tells me that it's something else, okay? I know, well, actually, I know that because x squared and y squared, the terms were both positive, I know that this is going to be an ellipse, which means in graphing form, it needs to be set equal to 1. So I need to divide every term by 16, okay? And if there's nothing there, I can put a 1 there. I'm going to rewrite this as x plus 4 squared over 16 plus this 4 over 16 simplifies to 1 over 4, so that becomes y minus 6 squared over 4. Now that is set equal to 1. So the center point for this ellipse is going to be at negative 4, positive 6. Right? I see that right here and right here. And I'm taking the opposite because of how the equation affects those numbers. So negative 4, positive 6. 1, 2, 3, 4. Up 1, 2, 3, 4, 5, 6. There's the center point for this ellipse. Now, when we're talking about an ellipse, the A value is always the larger value, right? So whatever the larger value is under, that tells me if my major axis is vertical or horizontal, okay? Because the larger term is under the x, that major axis is going to be horizontal. So I know this is going to be something like this, or I can write horizontal, okay? So the a value here, because that's 16, the a value is the square root of 16, which is 4. So I can go out 1, 2, 3, 4 in both directions. That tells me that my vertices are going to be at 0, 6, and negative 8, 6. Those are the ordered pairs for those vertices. And then now, if I want to find the b value, I'm going to take the square root of 4, which is 2. And I'm going to go up from the center and down from the center 2 units. Those ordered pairs are negative 4, 4 and negative 4, 8. And then if I graph this ellipse, it's going to look just like this. So let's move on to our last two examples. In this next example of a hyperbola, I can look at this equation and tell it is a hyperbola because all of my squared terms are on one side of the equal sign. One's positive and one's negative. So I can tell it's a hyperbola, even though this tells you that it's a hyperbola. The first thing I'm going to do is group my x and y terms. So 4x squared plus 32x minus 9y squared minus 18y equals, I'm going to move that constant to the other side of the equal sign. Because these squared terms have coefficients other than 1, I'm going to factor out a GCF. I'm going to factor out a GCF of my x terms and my y terms. So I'm going to factor out a 4 with the x terms, and I'm left with x squared plus 8x, and I'm going to be adding something in there to complete that square. In this next one, I'm going to factor out a negative 9, and I'm left with y squared plus 2y, and I'm going to be adding something there, equals negative 19, and I'm going to be adding something there and adding something there, right, to complete the square. So I'm kind of combining two steps into one. So now, what are we adding in order to complete the square? We're adding b over 2 squared. So in this first set of parentheses, b over 2 squared, b is 8, so 8 over 2 is 4, 4 squared is 16. I'm adding 16 to both sides, but actually, I'm not adding 16 to the other side. I'm adding 16 times the GCF. That's what you have to add to the other side, which is 64. So now let's move on to the second set of parentheses. b is 2. So b over 2 is 2 over 1. If I square it, I get 1 plus 1. What am I going to add to the other side? 1 times negative 9. I'm adding negative 9. I'm just going to write minus 9. So negative 19 minus 9 is 28, and 64 minus 28 is 36. Am I getting that right? Let me just make sure. 64 minus 28 is 36. Yep. Let me rewrite this in a different color. So now I get 36. This is going to equal 36. What I'm going to do is I'm going to factor these perfect square trinomials. So I'm left with 4 times, how does this perfect square trinomial factor? It factors into this binomial squared, right? I take half of that b. Minus 9 times y plus 1 squared equals 36. Now, I know this is a hyperbola. The equation for a hyperbola, when I'm graphing it, it needs to be set equal to 1. So I need to divide everything by 36. And when I do that, let's change colors here. When I do that, I need to simplify. 4 over 36 is 1 over 9, so I get x plus 4 squared over 9 minus 9 over 36 is 1/4. So I get y plus 1 squared over 4 equals 1. So now I can graph the center of this hyperbola. The center is going to be at negative 4, negative 1. I'm going to write that down, and I'm going to go ahead and graph it. 1, 2, 3, 4, -1. There's the center of this hyperbola. Now, this is going to open which way? Because this y squared is negative, I know that this is going to open horizontally. When the y squared is negative, that means it's going to open horizontally, and I'm going to write it like this. Opens horizontally, or you can write left and right, whatever you want to do, right? Horizontally, left and right. Another thing I like to do when I'm graphing is I know that transverse axis is going to be horizontal, and it's going to open like that. That's another way that I'll kind of designate. This is the way it opens. Okay, so now I know that the vertices are found from the values of A, and A is always under the positive term, which means this right here will tell me where my vertices are. So my vertices are going to be, if this is 9, that means the A value is going to be the square root of 9, which is 3. Which means from that center point for this hyperbola, I'm going to go out 1, 2, 3 in both directions. Those are my vertices. What are those points? -1, -1, and -7, -1. Okay, so now let's find the co-vertices. The co-vertices, I'm going to take the square root of the other term, which is going to be the square root of 4. So the B value is going to be 2. From that center point, I'm going to go up 2 and down 2. And those ordered pairs are -4, 1, and -4, -3. Now, how do I graph a hyperbola? Let's graph the asymptotes, which I just do this fancy schmancy rectangle connecting all the vertices and co-vertices through that center point, through the corner of each of this rectangle, every corner of the rectangle. That'll give me the slope or the line of that asymptote, okay? And now let's draw this hyperbola. We're just doing a little rough sketch. So that vertex is right there, that blue dot. I know it's going to approach each of those asymptotes on both sides, and it's going to look just like that. So let's move on to our very last example, which is a parabola. Looking at this example, I can tell that it's a parabola because I only have one squared term. It is y squared, which already tells me that it's going to open left or right. It's going to open horizontally. So what I'm going to do in this case is I'm going to group the squared terms on the left side, which means I'm going to group y squared minus 16y. Oh goodness, is this going to do this? Okay, equals, and I'm going to move the x term and the constant term over in this case, equals 3x minus 58, okay? So I've just grouped the y terms on the left because that's what I'm going to do to complete the square. I'm going to y squared minus 16y, complete this square, equals 3x minus 58, and whatever I add to that to complete the square, I'm going to add to this side as well. So when I do that, remember, I'm adding b over 2 squared to both sides. If b is -16, -16 divided by 2 is -8. -8 squared is 64. I'm going to be adding 64 to both sides. So now I can factor this perfect square trinomial. It factors into a binomial squared of y minus 8 squared equals 3x. When I combine like terms, 64 and -58 combines to +6. What I'm going to do now is I'm actually going to factor out a 3 on the right side. When I factor out a GCF of 3, I'm left with x plus 2. And now we can see that this parabola is in the graphing form that we're used to when we graphed parabolas in the previous lesson. So let's go ahead and talk about how this is going to open. I know it's going to open horizontally, and because this p, or that in front of that x term, is positive, I know it's going to open right. Okay, if that P were negative, it would open left. So it's going to open this way. So now where's the vertex? The vertex is going to be at -2, +8. So let's go ahead and graph that. That's right up there. And now let's find the focus. So I need to find the value of P. I know that my lattice rectum has a length of 4P, and that's going to be right there, equals 3, which means P equals, I'm going to divide both sides by 4, and I get 3/4. What I'm going to do is from that vertex right there, I'm going to move right 3/4, so not even a full unit, and I'm going to move left 3/4. When I moved left 3/4, that will give me the directrix. It's a vertical line. Moving left 3/4 gives me x equals -2 and 3/4, right? That vertex is at -2. I moved 3/4 more to the left. The directrix is at x equals -2 and 3/4. Now let's find that focus. The focus, because I moved 3/4 to the right, that focus is going to be actually at -1 and 1/4. And we're still at a height of 8, if you will. Okay? So those are those points. I know this is kind of a tricky one because your p-value is a fraction, but at least it's 3/4 and not like, 14, or not 7/14, 7/13 or something like that. So anyways, now let's find some more points, okay? So we can continue to graph this parabola right here. I can move 3/4, so from that point right there, I can move 3/4 down from, the focus. I can move 3/4 down, which is like 1.5. It's about right there. And I can move, well, it's 3/4 times 2, right? So I can move up 3/4 and up 3/4 again. That's 1.5. It's going to be about right there. And then I can graph it. So this is not a lesson over graphing parabolas per se. We are reviewing this whenever we do this. Not last lesson, but the lesson before was over graphing parabolas. But that does conclude your notes over converting conic sections from general form to standard or graphing form, and I hope it was helpful.